Hi everyone, in this video I'm going to be going over how to do stoichiometry, specifically converting from moles to moles. So from moles of one substance to moles of a different substance using a chemical equation. So in a spacecraft, lithium hydroxide, that's LiOH, is used to absorb carbon dioxide, which is CO2, breathed out by astronauts according to this reaction. Now, this reaction is not balanced, so the first thing we have to do is balance this chemical equation. If you ever see oxygens and hydrogens in a chemical equation, I recommend balancing those last. It'll just make things a little bit easier. So I'm going to start with looking at carbon. So there's one carbon here on the left-hand side and one here on the right-hand side. Great, those are the same. That's what I want. And like I said, we're going to balance hydrogen and oxygen last. So I'm going to look at lithium. There's one lithium here and there's two here. So that's not the same. So in order to make them the same, I'm going to put a 2 in the front here. However, when I do that, that 2 is also getting applied to the oxygen and that hydrogen. So this is now saying there's 2 oxygens here and there's 2 oxygens here. So that's the total of 4 oxygens on the left-hand side. And if I look on the right-hand side, there's 3 oxygens here and 1 oxygen here. So that's a total of 4 oxygens. So right now there's 4 oxygens on either side, which is good. This is also saying there are 2 hydrogens on the left-hand side. And on the right-hand side here are products. There's also 2 hydrogens. So this reaction is actually balanced. You can leave these blank or you can put a 1 in the front if you like. Again, the reactants are always on the left-hand side here, what you start with. And then the products are on the right-hand side. That's what you end with in a chemical reaction. Now, the question is asking how many moles of LiOH, or lithium hydroxide, are required to react with 20 moles of carbon dioxide. So we're going to set up our picket fence. We're going to start with what the problem gave us, which is 20 moles of CO2. Make sure moving forward with all of these problems, you are writing if you're dealing with moles or grams, and you also need to write the substance because we're going to be using different substances, so we have to make sure that we're writing that down. Also, moving forward, anytime you are doing a picket fence and you have moles, you need to use the balanced equation. This balanced equation, these numbers in the front, we put those there to balance the equation because you can't create or destroy matter. So the amount of atoms need to be the same on the left and right hand side of the equation. However, those numbers also represent moles. They represent a mole to mole ratio. And if we look at the reactants here, this is the best ratio for this reaction to occur. Going back to my picket fence, always do this for your second step if you're not sure what to do. Write the units here that will match up so that they can cancel in the top and the bottom. So I have moles of CO2. So that number is going to come from the equation, which is 1. So that's where I'm getting the 1 from. Now, if you pull a number from the equation, the number that goes above it should also come from the equation and should be the substance that you want your answer in. So above this, I'm going to put moles. And the question was asking for moles of lithium hydroxide, which is LiOH. So above that, I'm going to put moles of LiOH. And according to the equation, that is 2. So that's where I'm getting those numbers from. So this is how I'm going to convert from moles of one substance to moles of a different substance. So I'm converting moles of carbon dioxide to moles of lithium hydroxide, which is LiOH. And I'm using the balanced chemical equation to do that. So I would multiply everything in the top, 2 times 20, which is 40, divided by the bottom, which is 1. So my final answer would be 40 moles of lithium hydroxide, which is LiOH. This is something that you will have to do in every single problem moving forward. That's what stoichiometry is. It's using a balanced chemical equation to convert between different substances in a chemical reaction. This is very useful because it can tell you how many moles or grams, we'll get there at some point, you need of the reactant in order to get a certain amount of product. Or if you're looking for a certain amount of product, how much of a reaction or how many reactants do you need in terms of moles or grams, and we'll get to that point eventually. So this is very important in science because this can help scientists predict what's the best ratio in order to get the best results for a particular reaction. Let's do another example. So here's a very applicable one. So ammonia is NH3. Ammonium is NH4 plus, which is the ion of this. Ammonia, that's a very widely, first of all, it's used in a lot of cleaning products, but it's also used in fertilizer and, of course, household cleaners, like I said. And it is made by combining hydrogen gas with nitrogen gas. So again, the first thing I want to do is balance this equation. And like I said, you always want to balance oxygens and hydrogens last normally. So I'm going to start with nitrogen. There's 2 here and there's 1 here. So I'm going to have to put a 2 in the front. Now, in terms of the hydrogen, this is now saying 2 times 3. That's saying we have 6 hydrogens on the right-hand side, on the product side. So in order to make this 6 hydrogens, I will have to put a 3 here. So we have 6 hydrogens on either side. 3 times 2 is 6. 2 times 3 is 6. And we have 2 nitrogens on either side. 2 times 1 is 2. And there's 2 nitrogens here. You can leave this blank or you can put a 1 there. So now the problem is asking how many moles of ammonia, which is the NH3, are produced when you have 6 moles of hydrogen gas. The hydrogen gas is the H2. So we're going to start our picket fence with what the problem gave us, 6 moles of H2. So that would be the reactant right here. And we need to figure out how many moles of ammonia, so the product, that would produce. So again, this is always what you want to do as your second step in any picket fence, is the unit that's here, write the same unit here in the bottom because you're going to want them to cancel. So moles of H2. Where do I get that number that goes here? It's going to come from the balanced chemical equation. So 3 moles of H2. The number that goes above it, that should also come from the chemical equation. So moles and the substance that goes here, that's whatever you're trying to get your answer into, whatever substance you're trying to convert into. And in this case, this question is asking how many moles of ammonia, which is NH3. And according to the balanced equation, that is 2. Moles of H2 cancel in the top and bottom, and I'm just left with moles of NH3. So we multiply everything in the top. 6 times 2 would be 12, and then we divide by what's in the bottom. We have 3, so 12 divided by 3 is 4 moles of NH3 would be the final answer.